What's going on, guys? It's Cooper Codes. In this video, we're going to be creating a live news API using Apollo Server v4 in the graphql-ws library. The API is going to have an Apollo Server v4 subscription, which allows users to listen for any events that happen in our news feed. For example, we have a subscription running on the right, and if we send in an event from the left by running this mutation here, the person on the right is then going to see all the different data that the person on the left sent. We can even change the title here, change the description, and we can send in another news event here. And we're going to see that this person on the right who's subscribed to our news feed is getting every single event that's being passed through our API. All right, let's get into building this. We can get started by going into an empty folder and creating a server.typescript file for our server to live in. We can get started by installing all the different packages we're going to need for GraphQL and Apollo Server. So we can go into our terminal and start by saying npm install. Firstly, we're going to need @apollo/server for any of the Apollo server functionality. We also need @graphql-tools/schema for a schema building function. We're then going to need graphql-subscriptions to enable these subscriptions with a pub sub object, graphql-tag to access a tag where we can write GraphQL, and also graphql-ws, which is the WebSockets library we're going to be using for the subscriptions. So right now your dependency should look something like this. We are then going to download everything related to our actual server. So we're going to need an Express server, and we're also going to need access to the cores library, the body-parser library, and then the WebSockets library itself. This is going to help us build a server that has both HTTP functionality and WebSockets functionality. Now we're going to do some npm installs, which are going to allow us to run a TypeScript file on Node. So I'm going to use nodemon alongside ts-node. These are necessary for running a server.ts file locally. I know there are a bunch of dependencies, but finally we are going to need to npm install as a dev dependency. So --save -dev, the types for WebSockets and the types for cores because we're using TypeScript. So we can get the types from the WebSockets library by saying @types/WebSockets and then @types/cores. All right, so after all those installs, your package.json should look something like this. We can get started by telling our package.json that the main file is the server.ts inside this directory. We can also get started by defining some scripts. This is where you define your scripts such as npm run dev or npm start. For this video, I'm going to have npm start be defined as nodemon running the server.ts file. So if we say npm start, it's going to run nodemon server.ts. All right, let's get started building our server. We can get started by defining an asynchronous anonymous function. So why is it important that we define this function? It's because inside of server.ts, we need to use the await keyword. And so in order to use the await keyword, we need to wrap all of our code inside of an asynchronous function. We can do that by defining some parentheses here and then say async function. And because it's anonymous, we're going to give it no name like this, do curly braces. Within these curly braces here is going to define all of our different JavaScript code. And so now we just have the asynchronous function. In order to call this function, we can use parentheses at the end here to say, I want to call this function when server.ts gets ran. All the different code for our server is going to be within this function here. We can get started with some initial imports. We can now import an Express web server by saying import Express from the Express library. This allows us to define kind of the underlying server that all of our code is going to be built on top of. So we can say const app is equal to Express, which is a constructor that's going to build our server. We then want to have an HTTP server use our Express application to handle HTTP requests. So we can import create server from HTTP, and then to define our HTTP server, we can say const HTTP server is equal to create server using this Express application we just made. Now we're going to get started by defining our GraphQL typedefs and resolvers. Inside of our resolvers, we're going to use the pub sub object. So we have to define that by going to the top and importing pub sub from GraphQL-subscriptions. This is actually a constructor. So what we have to do is we have to say const pub sub is equal to a new pub sub object. Pub sub means publish and subscribe. So someone can publish an event, for example, and then everyone gets to hear it. And everyone hearing the published event is a person that's subscribed. And then finally, to define GraphQL typedefs, we need to import GQL from GraphQL-tag. This is because GraphQL can be seen as its own different programming language. And so when we define our typedefs by saying const typedefs is equal to, we actually want to start talking in GraphQL. And so we can use GQL and then 2 backticks to start processing stuff in GraphQL instead of TypeScript. So everything within the GQL tag is going to be processed as GraphQL code. And that should be typedefs there. So now we can define the types we want to have run on our server. For example, I need the type news event. So this is the structure of what information is going to be within the event that everyone is posting and listening to. Well, we want to have a title, which is going to be a string, and then a description, which is going to be a string. If you guys are interested in expanding upon this project, you can add a bunch of different variables to the news event here. We also have types that are reserved to certain keywords. For example, the type query is going to hold all of our different queries for the server. Apollo server requires you have at least one query. So I'm just going to make a placeholder query here that's going to return a Boolean. So that we can make this just return true by default, for example. We can also make a type of mutation. And so mutations are important for when we want to display data or create new data. Or, for example, have data be shown up in a subscription. So this is the process of actually creating the news event, but make sure this isn't the actual subscription quite yet. And so when someone creates a news event, we are going to need 2 different parameters. What is the title of the news event you're trying to create, and what is the description of the news event you're trying to create? And we can return just the news event object. So we can return their kind of finally created news event back to the person who sent it. And then finally, the important part of this video is we're going to define a type subscription at the bottom here. And I'm just going to name this subscription news feed, and it's going to return to the user a bunch of news events. And so this news event return means that whenever a user is listening for new data and they get a ping of new data, that data is going to be formatted in the way that the type news event is formatted. So if news event has a title and description and we're listening on the news feed, we know that all the different news events are going to have a title and description. And so that's it for the type definitions. Now we can get started by defining the resolvers logic for our server. And so the resolvers is a large object that allows us to define things like queries, mutations, and subscriptions. Our query is the easiest, so I'm going to define it first. We can say query : is equal to this object. And now we can define the logic for all the different queries in our app. We just have a simple placeholder query, so I'm going to say placeholder : is equal to an arrow function. We can point the arrow function to some JavaScript logic, and so we can define JavaScript logic by saying 2 curly braces like this. And inside of here, I'm just going to return true. So if someone calls a placeholder query, they're always going to get a true. And we just have this here because Apollo server requires a query to exist in your server. And so now we can also go into here and define the mutations. So we can say mutation is equal to an object, create news event, just like we defined at the mutation in line 26 here, and set it equal to some parameters, which again is going to be equal to an arrow function, and then curly braces to define JavaScript logic. Apollo server gives us access to some parameters though, so we can say _parent, and then args as well, which is going to be the arguments passed into our resolver. For example, we can look up at args here and see that's going to be the title and the description. Because we're using TypeScript, these parameters need to be typed. We're not using the parent, so I'm just going to define it as the any, but we know the object that is going to be used in our arguments. And so we can actually create an interface here. And so we can say something like create news event input. And so we can look at the news event input right here and see that it's going to have a title, which is a string, and then a description, which is a string. And so we can set the arguments type equal to this create news event input like this. And then check this out. This is pretty cool. Now when you say args dot, we're going to be able to see description and title inside of here, which is what we'd expect. Pretty neat logic. And so for anyone new to Apollo server, I'm just going to console.log the arguments. So if you guys want to see what is actually happening in our backend, we're going to see what the arguments get logged whenever we call the create news event mutation. We also know that the arguments is going to be formatted just like our news event is formatted. It's going to be an object with a title and a description. And so at the end of our mutation, we can return args. So we can make sure to return that news event at the end of our mutation here. Here's the thing though, when we create this news event, we want to make sure to ping our subscription. We can do this by saying pubsub.publish. When you publish, you're going to have a certain trigger name that you define to your event. For example, I'm going to say event_created. And this trigger name gets defined at 2 places. When you create something, and when you subscribe to something. So someone is going to subscribe to event created, and then when you create something, you're going to ping everyone on event created is how you can think about it. And then we want to pass in the payload to our publish. And we're going to put an object which is going to match the name of our subscription. So we're going to say, okay, the name of the subscription is news feed, like this. And we want to pass it a type of the news event. Well, we know that news event has a title and description like this, and our parameters are a title and a description. So we can set that news feed equal to the arguments. Whenever we create a news event, we are going to publish to the event_created right here. I will note something important that we're not doing in this video. If you want to save news events to a database, for example, you can do that here. So if you want to get all the different events that have passed through API and save them to a database, you can do that here. But in this video, I'm not going to be doing that. Now, finally, we are going to define the subscription of our resolvers here, set it equal to an empty object. And so we can define if we ever subscribe to news feed, like we defined in the type definitions. What do we want to do on the subscribe event? Well, we can make an arrow function to define the logic of when someone subscribes, what do we want them to do? We want to use something called the pubsub.async iterator. An async iterator is going to be waiting for a certain event to get triggered and just be waiting to give the user a response for that certain event. And this is why we talked about the trigger name over here, is because we use the same string down here. And so when someone is subscribing to events, what they're doing is they're asynchronously waiting for event_created to get pinged. As soon as it's pinged, for example, with a publish up here, this person subscribed is going to receive the data or the payload of the actual publish. And so in this payload, we can see that we are going to get the arguments here. And so that is how users are able to get live data. So that is all the logic of our Apollo server, but we still have a couple things that we're not doing quite yet. So I'm going to comment out the rest of the things we need to do to build this Apollo server into something that is production ready. We need to start the WebSocket server because subscriptions run over WebSockets and not HTTP. We then need to finally create the actual Apollo server, which is going to run with everything together. We then need to finally create the actual full Apollo server. We need to start our server, and then we need to apply middlewares. This is stuff like cores, any express middlewares, but I'll explain this more in detail when we get there. Then we need to also have our HTTP server start as well on a certain port. So I know this is a lot of different steps, but this is what it kind of takes to make a production-ready subscription server. The great thing about a tutorial like this is you're actually building something that could get used by a bunch of different users and actually be able to, allow maybe thousands of people to listen to certain events. So for the WebSocket server, we're going to need two different imports. Firstly, we are going to import WebSockets server from WS, which means WebSockets. And we're also going to import the use server from graphql-ws/lib/use/ws. And while we're up here, we're also going to need to create a schema from the resolvers and the typedefs that we made recently. So we can do that by saying import make executable schema from @graphql-tools/schema. All right, so let's get started by going down here. We can get the schema out of the way by saying const schema is equal to make executable schema. It's going to ask for the typedefs and then also the resolvers. This is a pretty simple line of code. What it's doing is this is a relatively simple line of code. What it's doing is it's making a schema that our Apollo server can use based off our typedefs, which we defined, and our resolvers, which we also just defined. We can define our WebSocket server by saying const ws server is equal to new WebSocket server. We are going to run WebSockets on top of our HTTP server. So that means we have to say the server it's running on top of is equal to HTTP server. And we want the HTTP server to be able to run WebSockets only at a certain path. And so we can say path is equal to /GraphQL. So this would be something like localhost 3000/GraphQL. In order to fully kind of destroy the WebSocket server, what we need to do is we need to make a const for the server cleanup. And to get access to the WebSocket server, we can say use server of a certain schema, which we defined above, and of the WebSocket server. This server cleanup gives us access to a dispose function, which means we can fully kind of tear down our server the correct way, if you could think of that. Here's a big one, is Apollo server. For Apollo server, we're going to need two different imports, so let's go get those. We can import Apollo server from @apollo/server, and these should be in curly braces like this. This is the most ridiculous name you've ever seen in a tutorial, but we need to import Apollo server plugin drain HTTP server. So this is going to help us tear down our HTTP server that the Apollo server is running on correctly. And it's a helper function from @apollo/server/plugin/drain HTTP server. Pat yourself on the back because that's probably the longest import statement I've ever seen for just one thing. All right, let's go build our server now. We can say const server is equal to new Apollo server because Apollo server itself is a constructor. And a thing to remember with constructors is they generally require an object to define exactly how you want something to work. Like, how do we want Apollo server exactly to work? First of all, we want Apollo server to use the schema that we defined above. So use the typedefs and the resolvers so we have the actual logic we would expect to have on our Apollo server. And then we can add some plugins, which is stuff that we can add on top of Apollo server, which is going to be an empty array initially. We are going to put the Apollo server plugin for draining the HTTP server, which is going to get access to HTTP server like this. So it's going to tear down the HTTP server. And then you'll see we have this WebSocket server. This also needs to be teared down. And so we can make an object inside of our plugins here and make an asynchronous server will start, which is something we get access to from Apollo server plugins. I wouldn't stress this too much, but pretty much when the server starts, it's eventually going to return. And inside this return statement, we can asynchronously say drain server. And so as soon as this drain server gets called, what's going to happen is we can say await server cleanup.dispose. And so what this is doing is it's saying, okay, we also want to fully dispose of the WebSocket server as well as the HTTP server. So we can kind of dispose of everything at once. Like I said before, guys, it's a lot of steps, but we're really getting something that's production ready. Now we can finally do the await server.start. I know there's a nice line of code after all that craziness, just a nice start the server. Okay, so now it's time to apply some middlewares. Let's go import some stuff. We need to start by importing the ability to add express middleware by saying import express middleware from @apollo server/express4. We are then going to import cores from cores. This is going to allow any origin to access our API. Then we're also going to import the body parser, which allows us to parse JSON bodies from body-parser like this. And so in order to apply these middlewares at the very outer lying thing, think about what we made initially. We made an express server at the very top here, even though it was a long time ago. We made the express server here. And so we can apply stuff to the very kind of outer shell of our server by saying app.use. And we can apply stuff specifically to a certain route by putting in a string initially and putting in the route. So /GraphQL. Then to define how we want the app to actually work, we can use a bunch of different things here. For example, we want to define cores, which means accept things from any origin. Because we're in TypeScript, we unfortunately have to define the cores.cores request like this, or else it's going to get angry at us. We also want body parser to be applied to our Express application by saying bodyparser.json. And then a big one is we want express middleware to be run on our Apollo server. This is pretty much saying that run Apollo server on the Express server. Because Apollo server itself is going to start and it's going to be its own unique thing for a while after this constructor. In order to apply it to the actual Express server on the way outer shell, we need to say express middleware with the server here. All right, guys, now at the very end here, and yes, this is the end, so don't get too excited or click off the video. Just kidding, do what you want. Now we can say HTTP server.listen to a certain port. For example, I'm going to run this on port 4000, and then you can define the logic of the listen here. So we can say, all right, go in here, define some logic, and we can say console.log server running on http://localhost : plus 4000, or the string 4000 here, plus /GraphQL. So localhost 4000 /GraphQL is going to be running our server if we get to this point. So now we can look back to our npm start over here and see that when we run npm start, it's going to run the server with nodemon. All right, guys, let's start our actual application. It looks like things are working, but let's not get too hopeful, and let's go over to localhost 4000 /GraphQL. All right, so when you go to localhost 4000/GraphQL, you should be meted with a page. It looks something like this. On the left here, I'm going to create a mutation by saying plus to the mutation, and I'm going to create a news event by saying plus to this create news event feed. And then we want to add two arguments, the title and the description. And so the title and description are defined as variables at the top here, and I'll zoom in. And these variables are going to be defined on the bottom here. So I'm going to say for the title, thanks for watching. Description is going to be subscribe if you want. And when we create this news event, I'm going to ask for the title and description of the event we just created. And so let's run this mutation. All right, so a status of 200 means we got a successful request and is giving us back that event we just created. If we go back to our console, we should expect that we also are seeing the event get logged here, so we can see that working kind of full circle. If you didn't add the console log, don't worry though. All right, guys, so make sure to keep this mutation here because I'm going to use it in a second. So guys, do not delete this. Go and open up localhost 4000/GraphQL on another tab, and let's get started by building the subscription. So we can say plus to subscription here. We can then add to the news feed here. And then from the news feed, which we're subscribing to, what data do we want? Well, I want the title and description of every single news event. And as you guys will see, we're not using any variables. You don't see any $ here, so we can get rid of the variables on the bottom here. So now we're actually listening for events to happen. If we go over to our other tab here and run a mutation, we're going to see that, let's go, we have a subscription being ran, which can show a user who's subscribing the current data that another person just kind of threw into our API. And so I'm just going to make this a different title. I'm hilarious, I know. And then for the description, I'm just going to make a different description. Yeah, I know it's probably the funniest joke you've seen in your entire life. And so we can see that we are getting a different title and a different description over on the subscriptions over here. All right, guys, so that is the full video. Hopefully you guys learned a bunch about TypeScript, Apollo server, and especially the new stuff you have to do for Apollo server v4. Setting up a subscription server with WebSockets, the ability to have WebSockets and HTTP requests is not an easy task at all. And so I just want to say, guys, thanks so much for watching, and I really hope you got a lot of value out of this.